Okay, so what we're going to do now is we're going, and this is really the final thing, that new thing that we'll really show you, is we're going to find out how we use when we have a steel shape, how we'll use the steel shape and the properties that come out of the table for that steel shape, how we use those in finding the moment of inertia for a composite shape. So earlier we found we had a plate that was sitting on top, maybe welded to a W10 by 45 steel section, wide flange section, and we found that the x-axis for this combined composite shape was lying down from the top of the plate a distance of 3.42 inches. Okay, so that's where the centroidal axis for the composite shape lies. Let's find the moment of inertia about this axis for this composite shape. So what shapes do I have? Well, I got the plate, and I've got the W10. Okay? For the plate, the moment of inertia about its x-axis is 1/12. The base is 12, right? And the height is 1. So 1 cubed. So what's the moment of inertia about the x-axis just for that plate? 1. The area of the 12 by 1 plate is 12 inches. Now, here comes the hard part. What's the d distance? What's the distance between the axis, which I just calculated moment of inertia for, and the axis that's for the whole shape? 2.92. Because the axis for the whole shape lies down from the top 3.42 inches. The axis for just that rectangular plate lies down a ½ inch. So the distance between them, 2.92. I take 2.92, I square it, and I multiply it by 12 inches, which is the area. What do I get? .92 squared times 12. 102.3. IX plus 80 squared gives me 103.3. Okay? Everybody see that? Okay, now, the W10 section. This W10 section has an x-axis, a centroidal x-axis, and if you look at the table, for your tables on page 602 and 603, you can see there that it has on 603, page 603, an x-axis and corresponding properties. And one of those properties happens to be I, moment of inertia. So if I look down at a W12 by 45, or 10 by 45, and I look at the moment of inertia about the x-axis on page 603, what do I get? What does the table give me? 248. Again, that's inches to the fourth. So there's nothing to calculate. You simply pull this out of the table. What's the area for a W10 by 45? 13.3. We found this earlier when we were dealing with centroids, right out of the table. Okay? Now, here's again where it gets a little bit difficult. What's the d distance between where this axis is down here and the axis that I'm calculating moment of inertia about for the whole shape?
Is the depth the height of that?
The depth is the height of, yeah. The overall depth, you get this out of the table, they told us was 10.1. So now what's that d distance? Well, how about half of this is 5.05, right? Plus another inch. So this axis is 6.05 inches down from the top. The axis for the entire shape is 3.42 inches down from the top. How about 6.05 minus 3.42? What's that? 2.63. There's D. Take D, square it, multiply it by the area. What do you get? .63 squared, and then multiply that by 13.3. 91.99. Let's just call it 92. Okay? IX, about the centroidal axis, plus 80 squared, 248 plus 92. That gives me 340, right? Okay, and then I just total it up. So my moment of inertia is 443.3 inches to the fourth.